To begin today, we have our warm-up like usual. So when we are looking at the warm-up, our first one says to solve. And all we have to do is simply figure it out. And notice that we're using all division. And so since all our operations are division, we're first going to do what's in our parentheses. So we have to figure out 64 divided by -4. When we break that down, we get -16. And then recopy what's left, divided by -2. And now all we have left is -16 divided by -2, which gives us a final answer of 8. Notice we went left to right, and we did parentheses first. Now, over on number 2, it says find the actual area of the rectangle shown in the scale drawing below. And it gives us a scale of 1 inch equals 3 feet. I like to set up proportions. So I know 1 inch is 3 feet. So I know 4 inches is how many feet? To solve, we've done this in the past. Cross multiply. 3 times 4 is 12 equals x. So 4 inches is 12 feet. We can do the same thing for 8 inches. 1 inch over 3 feet equals 8 inches over x feet. Cross multiply and we get 24 equals this x. So 8 inches is the same as 24 feet. And remember, because it's asking us to find area, area equals length times width. So 12 times 24 gives us a grand total of 288. Our label is square feet, or feet squared. And there we go. Today's I can statement is I can calculate percent error in real-world situations. Percent error you'll learn a lot more about in science the further you go. And you can also apply it to situations like weather predictions or predictions of any kind that involve numbers. In order to find percent error, we first have to figure out how we find error, and then we apply that to finding percent error. And percent error and error have to do with absolute value. So remember, they're like the lines around your number. An absolute value results in an always positive number. And this will always make our percentages positive. So when we find our error, error is the absolute value of the estimate minus the actual, or the exact number. So absolute value of your estimate minus exact, or your actual, whatever you want to call it. Percentage error is your error, which was that number right up there, divided by the actual, or exact. And so error was the number above us, and then actual or exact is the same down below. So error is this whole thing, and actual exact is the one circled. However, when you do this, it produces a decimal. And remember, you have to then multiply by 100, and we'll end up with our percent. Don't forget this multiply by 100 step at the end. Otherwise, your answer will be in decimal form and not percent form. So let's go ahead and give this a try. In science, you had to measure how far your Matchbox car went. You found that your car went 29 meters. However, it actually traveled 32 meters. What was the percent error in your measurement? So remember, we first need to find the error and then we find percent error. So let's start with error. Error, remember, is our absolute value of our estimate of 29 minus the actual or exact of 32. 29 minus 32 is -3. But because it's the absolute value of -3, our actual answer is simply 3. Because remember, it's always positive. Now we're going to put it in our percent error equation. So percent error equals the error number that we found, or 3, divided by the actual of 32. When we divide, we end up with 0.0938. However, remember, I said this is a decimal. So we need to multiply by 100 to get our percent. When we multiply by 100, we end up with 9.38%. And so our percent error in our measurement is 9.38%. And that's it. Our next example says that on the news last night, the weatherman said that today's temperature would be 19 degrees. However, today's high temperature was only 13 degrees. What was the percent error of his report? So, because he said that it would be 19, this is his estimate, which makes it that it was only 13, our actual, or the exact. So now that we have everything defined, we can find our percent error. I like to start with the error. So error equals the absolute value of our estimate minus the actual, which gives us the absolute value of 6, which equals simply 6. Note, always a positive number. We now put this into the percent error equation, which is our error of 6 divided by the actual of 13. When we figure it out, 6 divided by 13 equals 0.4615. However, remember, this is a decimal. We need to go to a percent. And in order to do so, we know we take our decimal, 0.4615, times 100 to make it a percent, and we end up with 46.15%. And so his percent error was off by about 46%, and that's not a very accurate prediction of the weather. Our next example says that Alex expected to get a total of $55 for his birthday, because he was planning on using the money for new headphones. However, he actually received 78. What was his percent error in his estimation? So he expected this, so this was his estimate of $55. He actually received this, so that would be our actual. Now that we have everything, let's find our error. And remember, error is absolute value of estimate minus actual, which gives us the absolute value of -23. And remember, it's always positive, so our answer is simply 23. However, that's only the error. Let's find our percent error now. Percent error is error, or 23, divided by actual, 78. And this equals 0.2949. However, remember, this is decimal, and we need to switch it to percent. So we take 0.2949 times 100 to switch it to percent, and we end up with 29.49% for our final answer. Our next example today is a little different than the last few. So when I was guessing how many jelly beans were in the candy jar, I was off by 40 jelly beans. If my guess was 28% off, how many jelly beans were actually in the jar? So, set it up just like always. Error. What was our error? Remember, typically we do the absolute value of our estimate minus exact. So it's a positive number. It's how far away we were from the right answer. And that's what this is. Off by 40 is our error. So error is 40. Next we do percent error. And it tells us our percent error was 28%. However, when we write percentages in formulas, let's look at this as 0.28. Now, using error and using what our percent error is, we're going to set up our formula. Because remember, it's percent error equals error over actual. So, percent error, 0.28, equals error over actual, which is what we are finding. And then we simply solve. Put it over 1 and cross multiply. 0.28x equals 40. Divide both sides by 0.28. And we end up with x equals 142.86. However, because we're asking about jelly beans, we can't have 86 of a jelly bean. So we're going to say about 143 jelly beans were in the jar. We followed our same process, but it was asking for a different answer than what we're used to. If we take our processes that we're used to and we slowly walk through it, you will be fine.